The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds.
Hello, everyone, and welcome. My name is Nathan, otherwise known as Old Man Builds, and today is going to be a great and glorious day. We get to talk about holes today. Apparently, science believes that we are in a black hole or in a hole of some kind. Isn't that ironic compared to what we talk about on the show, man? All about the holes, apparently. Oh, I love it. Oh, man. Yeah, Gerald did make a call that you can put your fist through the hole. Oh, now we see the whole picture. Well, apparently, man, they suck you in. That's the way these black holes work. Oh, oh my God, dude, I can't believe that they actually said this in physics. So, what they're trying to tell us is that we're actually inside of a black hole. Can you believe that? At some point, we got sucked in from another universe and we got put in this black hole. Is it like a timeout? Is that what we got? Are we in the middle of everything? Are we in the null zone? I mean, seriously, what are they trying to tell us? I just think it's ironic and funny. They keep bringing new stuff to the table, and it didn't make any more sense than the last stuff, but it sure gets funnier. I'll tell you that. Yeah, what did they drink this time? There you go. We all get in trouble with the black hole when we drink, don't we? Yeah, that's when your mommy and daddy tell you to stop doing that kind of stuff and grow up, huh? Oh man, this is so great. Oh, we're gonna have to check in with Mike later and see how many holes there are, because I think there's more than one. They said that there's more than one black hole in our universe here, because it's better than a brown hole. I just don't understand, man. I just don't get it. Why can't they just accept that we're out here in the universe, man, and that I mean, we just exist. I mean, we see, or the telescope, they say they see black holes, okay, but then again, they say they don't see the face on Mars. So what am I to believe here? We all know that there's certain things there. Maybe there are black holes. That may be the one saving grace. And then they tell you, oh, by the way, their cousin, the white hole, is over there too. So now we have black holes and white holes. Now maybe the brown hole's coming. Maybe, the brown pants day, they're going to say, okay, now we have a brown hole. Maybe that's where we're going. I mean, wow, this is bad, man. I mean, how far were they steep lower? I'd love to tell you something great about physics here, and that, you know what I mean? They say that you fall freely into the black hole. I don't, that hasn't been my experience. You maneuver towards the black hole, you don't fall freely into it. Well, some people might. I mean, look, if you got that problem, man, strap a board to your butt, man, because you're going to be in for a wild ride. I'm sorry, man. It's just you have to make fun of the absurdity of it. It's like, what will they say next? I mean, what kind of headlines would you want? Yeah, you got yellow holes. Yeah, man, this is bad. This is bad. Yeah, rainbow days these days. It says that it sucks in all light too. So you get no rainbow days. None. No light exists in a black hole. Apparently, it can't get out. It's like a little swimming guy that goes to the top of the hole, and the hole rejects it, so it's got to go back down. That's what they told me. They also said that there's like a river where everything just goes and flows into the hole freely. Well, that's a hole that needs to be plugged. You can't have free flow there, not like that. Yeah, I don't know about that, man. Black hole seems like some serious business. No light can escape it. We can't get out of its gravity. You free fall into it, but then you gotta claw your way out. Is that the way it works? Man, I know I'm having fun with it, but look, the bottom line is, man, just make up your mind of what it is. This is getting bad. Like every week, it's something different, and it gets more absurd. Hey, how did they measure the black hole? Oh, they took a laser to it. Ah, that's all they know how to do. Wow. Did you graduate physics? Yes. Oh, well, let me take you to the laser store. We're going to buy you about 10 lasers, and you got to have some extras for the garage, just in case your laser burns out. We got to get you another one. Got to make sure you have plenty of lasers, okay? And then we're going to bounce them off stuff. And then you're going to predict the future of the world. Got my crystal ball here, baby. We could just use it. Yeah. We got a little magic 8-ball. We can shake it up. Yeah, there we go. Yeah, lasers? Are you kidding me? That's the only thing you do? When you know full well that it takes a magnetic field and, you know what I mean? Just that whole thing. And light is basically how the wave goes through it. That's it. There is no light in dark space. You're not calculating that. I mean, for God's sakes, man. Well, why are you trying to lie to us? We already know that that's not true. There's no light there. Okay? Light is only when something comes in contact with some kind of a magnetic field, you get light. And it has to be out of plasma, and then you go into light. I'm sorry, man. We know how it works because we can build this stuff now. We're not, we don't have blindfolds on. We're not walking around the forest with blindfolds, man. We get it. Okay? You can't lie to us about this stuff. Oh, man. Lasers. How many experiments can you do with lasers? Let's make our whole physics about lasers. I don't like it, guys. I don't like it. Not at all. Got a bunch of holes out there that we get sucked into and can't get out of. We got lasers everywhere telling us exactly what everything does, apparently. And we go past the obvious. We go past the obvious things that actually work. You know what I mean? Like, oh my God, this resonance works and it creates some, energy in another thing that it shouldn't just by the actual frequency of it. And you go, well, that can't be quantum entanglement. It has no lasers. Our lasers didn't go in that direction, buddy. That doesn't work. That's what it is. That doesn't work because our lasers did not go in that direction. I mean, it's ridiculous. Some guy set lasers, okay, literally, and did a whole thing on it. He just wrote it up. You know what I mean? This is his laser check sheet, and he went through it, and then he wrote it up as a science formula, and they spent millions of dollars on it, and they published the paper. I mean, you're kidding me, right? That's what you got paid for? Like, I'm in the wrong business, man. I need to invest in some lasers, go down and get me a degree, and then I'll make millions of dollars. Yeah, and I could just play with my lasers all day. That's it. Do you want time travel? Let me just start up my lasers. Got some nice green ones that'll get you there. Yep. I bet you they tell them with the brochure with the laser, that's how it works. Yeah. These people, man, I tell you, it gets worse and worse. That's why, look, man, I know there's black holes. I know there's a serious side to this, but you got to make fun of the absurd. Okay, you just have to call it out for what it is. How many people got paid for this research to happen? Seriously. I mean, how much money did you get out of that paper for those lasers? I mean, you're really just taking advantage of us. I wouldn't pay for that study. Not a chance on God's green earth would I pay you to play with your lasers. You didn't even understand that if you put something in a vacuum chamber and then it had a thickness over 1 inch of polyurethane, that you're not going to get some kind of refractive value. Didn't even bother to look at that. Lasers out in the open. Oh, but that vacuum chamber's there, right? Well, I'm sorry. Your experiment sucks. You needed to have all the lasers in the vacuum chamber itself in order for it to work properly as an experiment. Keeping the lasers outside while you put it into a chamber doesn't work. I'm sorry. And it just does not work. Oh, man. Yeah, I tell you, man. Yeah, we're going to use lasers for a replicator too. That's the next thing. We got to spend billions on it. Okay. No sense in giving anybody that actually has some talent to do it. They're just going to give them some lasers. There we go. Black holes. We'll talk about that stuff too. Okay. We're just going to make the biggest, blackest hole we can and tell them everything we can about it. Because if they go to find out, well, they'll just get sucked into the hole, won't they? So we won't ever hear the rebuttal for it. They figure, well, we can get away with anything. Make it as big as we want, as small as we want. You know what I mean? We can make it fluctuate, whatever. They'll never find out because when they get a hold of a black hole, they'll just get sucked in. Hey, I guess if that works for you. Yeah. Yeah, how else you get? There's the black hole right there, the funding. That's the black hole they should be talking about in physics. Where's all that money gone? I mean, lasers don't cost all that much. I mean, seriously, where did all the rest of the money go? Yeah, going through walls. Yeah, I never seen a laser start doing that unless it's cutting the wall. Yeah, I'm sorry, man. I'm not with this thing at all. You know, you come up with real science and then they sit there and they talk to you about the word salad that they like to use. And then they tell you their idea. And you're just sitting there looking at them like, how the hell did you get a degree? Like, how did that happen? How did you write this paper? And why am I reading it? And then how did you get your degree? This is impossible. This is why nobody believes in it anymore. I mean, I would rather believe in UFOs all day instead of believing in one of these people who does this. You can't predict time travel on a laser. There's no association with it. You cannot predict the speed of light with it. It doesn't work that way. It's the speed of energy. You're not even in the ballpark sometimes, man. But then again, if you deal with lasers, speed of light makes perfect sense. But just ride the laser. Not to mention the big cuts you get down your rear, but you're just going to ride the laser. Oh, yeah. I don't know how they would get a patent on that. I mean, what are you going to do with the patent once you read it? Oh, I got the patent. I read it, and it said to set up my laser here, and I went to these 4 points. And then I got meters to read it. That's what I did. That's how physics said to set it up. I don't know how many times I've seen it. I mean, God, just stop already. Sometimes you just got to call it the absurd for what it is. Look, we know there's black holes out there, but is it going to be continuous forever in a black hole? Probably not. You have to have energy created in a star in order for the star to function. Once it stops functioning, it becomes a dense mass. If there's anything there. I mean, what was at the center of it originally? See, your calculations based on the sun actually being mass. What if it's not? See, what if the mass is in energy and it's holding in energy and that's all that's going on and it makes transmutation in it? So the core of it may have mass and density in it, but the rest of it may not. So once it dies, you say, well, it shrinks down. Yeah, well, because that's the energy layer shrinking around it. The density is going to be the same thing that it was in the beginning, but you're not going to have the energy level. It may die out and just become a rock. I mean, it doesn't make any sense what they're saying. How do you have hydrogen reserve in a sun? You don't. You either fundamentally make the hydrogen and then it starts to combine with other atoms, or you don't. You don't have reserves. It's not like, oh my God, we got this reserve tank. It would blow up. We already know that one. Okay. A lot of us out here are rednecks. We've already lit stuff on fire and watched it blow up. We already know. We can tell you firsthand information. It does not work that way. Of course, the star is going to burn down to almost nothing because it's losing all the energy value in the transmutation stage, which is the outside layer of it. Oh, I'm not even sure the patent was given, man. Wow. Major UK breakthrough in Rosetta Watch lecture last week previously required crypto cooling. You know, they don't understand energy. I'll just say this. They don't understand how you can get cold amps. We all know it. Take your magnet, put it on iron. You're going to get cold amps. It's what Bearden always talks about. It's the free energy portion of it. It's amps without heating. That's what it is. It's also why magnets work in a particular way. When you shell a magnet, the magnetism that goes out of it goes into the iron, and it cannot equalize itself into the iron. There's too much iron there. So what happens is the energy field goes down and makes it real dense and small where it does not come out of the shielding. That's why you shell them in iron. You don't shell them in aluminum. Aluminum has a repulsion value, not a knock it out value. It's just different. Some of these things that are on here, man, the cold is what makes your energy work. Think about it, man. They want to talk about entropy, right? Well, yeah, make it colder and it'll run longer. Without the hysteresis in it, without that heat, you're going to run 10 times as long. The colder you can make it, the more properties it's going to gain towards superconductivity. We all should know that by now. That should be fundamental science. So you'd never run your system hot if you could. But we all build systems that are pushing the amps through the system. You want a system that runs a high amount of power? Well, they're using the opposite side of that. They're using the PMP, so they're pulling the cold through your system. Yet physics is always about what's the hot system, what's the sun, what's the stars. Well, maybe there's more energy around it than the star itself. Never thought about that? I watched something the other day, man, and they're talking about how does the sun work towards the earth, right? Well, apparently, according to them, the energy comes off and goes this little wave and goes to the planet. The planet receives it, and then after it uses it, it bursts it back out. That's a big line of horse shit if I ever heard it. Okay. I had to put my boots on up to my thighs, man. That stuff was thick. Okay. Heck no, it doesn't work like that. Why would that ever work? What if you took your little spaceship and you put it between the sun and the earth? Are you getting those waves? Are you getting fried like that? No, there's nothing out there. Oh, well, it tunnels. Oh, really? Can you make the tunnel work in a lab? No. Oh, well, we just stepped in some more. Let me get some waders on and let's continue the conversation. It doesn't work like that. The only thing that quantumly entangles is resonance. It's the only thing that you could turn on and have it turn on something else somewhere else without anything in the middle of it. That's the only way it quantum entangles. The way they describe it, it's something that may work in a lab with a laser, but it has no place in physics, not in the way that we have things around and what we're really observing in nature. It doesn't work. I mean, we see it all the time, man. Nothing works like a laser out there in space. Okay, even those by the time you get to space will be outdated. You're going to need something with phase conjugation in it, and you're not getting there with a laser. We got things that do for crowd control that can actually destroy everything in your body right now. every single cell that can destroy it. It's why they use them. They don't turn them up to that level, but they could. What do you think the Ark of the Covenant was? It's the same type of machine. It wasn't meant for that purpose. Could be used as that. You know, yeah. We're looking at portals too. They wanted to tell us, okay, the black hole will be our portal, right, to an Einstein-Rosen bridge. So you go in there and you get smashed to bits and you come out, you know what I mean? Apparently, this is how poo is made. You get smashed in there, okay, and then you come out the other hole. Go in the black one and come out the white one. I don't know why they call it a white hole. It should be a brown hole, but whatever. You get smashed and put through there. The portal will never survive, right? No. I'm sorry, man. It's absurd. It's just absurd. I mean, we see it all the time, man. We have all seen tornadoes. The eye of the storm is the calmest. So, what would be in the middle of an Einstein-Rosen bridge? The calmness. Or are you being pulled and sucked out into somewhere else? Maybe. That might be entirely possible because there be enough gravity in there. Well, if there's no energy in that star, there probably isn't any gravity. You have a dense object. The gravity intensifies as it burns out, but once it's burned out, I don't think it has any gravity. I think it becomes a basically inert object in the solar system. It may even explode. Okay, who knows? But gravity is based on energy. And if you haven't figured that one out yet, good luck. It's energy based. So once you burn up all of the fuel into the star or stop producing hydrogen, and guess what? You have no gravity to it. So will it become a black hole? No, it's probably nature's way of getting something out of our universe. It would make the most sense. There's an imperfection in it. It has to leave. It's got to go. So they pull it out. That's generally how most systems in nature's works. You know what I mean? If it's going to be decay, it's going to decay everything and eliminate it. And there goes the plant. You cut off the decay and then, the plant continues to grow nicely. There's no continuous succubus. I mean, this isn't your ex-wife here sucking all your money out of your pocket. That's not what's going on here. There's going to be a finite end to it. Once the energy's gone, you have no gravity. It's gone. It's like our moon. There's no gravity on our moon. Our moon is held there by our Earth, and our Earth puts its gravity field around it. I bet you on the far side of the moon where we can't get to, there's going to be less gravity on it than there is on the side that we can see. It fundamentally makes sense because there is no gravity on the moon. It's not naturally produced on there. There's nothing working on there. The only energy coming into it is the symbiotic relationship it has to our planet. It doesn't have it on its own. There's a lot of misunderstandings out there in how all this stuff works. You think about it and they always say, oh my God, we got a magnetic field. Well, yeah, you do. But is it the main thing? No. It's rotation of a electric field that creates the magnet field that comes out of the Earth. And based on the rotational speed, you have this field that builds out and then it pulls in. And then you get different values that go on in there. You're not just having magnetism when you get to that level. The magnetism becomes very, very low. Okay? When you get out to space. You say, well, that can't be because we have a magnetosphere. Well, okay. All right, genius. What part of the spaceship out there that's metal is it magnetized to? Well, no, it's not. It dissipates by the time it gets out. Well, you just said it was strong. The truth is, it's not out there. Why? Because it's dissipated by then. Your electrical field is dissipated by then. You're left with radiant energy out there. You got a lot of radiation out in that area. As soon as you get out there, we all know this. Okay? Some of these things, man, they need to think through better. And they go, oh, well, you're just electric universe. No, the only thing wrong with that is its name. All the rest of the principles they put forward are solid. And anybody who doesn't think that hasn't even looked into it and learned it. They're just some pompous a-hole sitting there saying something. I'll tell you this, man. You change the word to energy and you'll be just fine. So, yeah, look, we'll have some fun today. Some black holes, some how big are they? How tight are they? I mean, seriously, man. It's just, I don't think it's a truly. I don't even know why they said it. Okay, it's like what absurd thing can we make them believe now? I think that's the game that physics is playing. What can we get away with that they can't check? Like, can we just say anything we want? You know what I mean? I mean, Star Trek tried to get away with that, right? Remember, they made the aliens look like turds. Do you remember the turd guy, the brown guy? He looked like a turd. Okay, and they passed him off as the new alien race. And I'm going, man, Star Trek gone downhill. They just throw anything out there and say that it works. No, it doesn't work. Man, I think that's what physics is doing, honestly, when they come up with this kind of stuff. Do we understand there's black holes? Yes. That's not what I'm disagreeing with. Are we in a black hole? No. Okay. No. We are not in a black hole. Is space-time real? Well, the fact that you're positioning in it is real. Okay. You have a X, Y, and Z axis. Yes. Is it a flat plane that builds its little hole for gravity? No. Okay, get out of your little 2D Tron universe, get into the new century to the 3D version, and let's start reworking this whole problem. It is not a little flat plane that has a dip in it. Okay, I'm sorry. That doesn't work. And they say, well, we'll just take out the planet and we'll put a black hole there. It's the same thing. Well, it was shit in the beginning with when you talked about it. That whole idea was crap. Okay, now you want to add more crap to it? Now I know you're pulling my leg, okay? Now I know you're asking for it, okay? Because that ain't how it worked in the beginning. We don't live in that kind of a universe. We don't have a flat plane anywhere. You go, but Nathan, the Earth is round, and then from the center of it, we have a flat plane that builds out the whole solar system, and everything's on this flat plane. But that's not even true. Everything is in a different position. They must be looking at the science textbooks and saying, they drew it straight across. Look at that. We got something there. No, not the way it works. You got things all over the place, man. Yeah, they can find area like this and go, you know what I mean? I can't even do it right. Get to a big area and go down to a small, yeah, because the sun puts it out, but the sun puts it out, you know what I mean? Like this. Oh, I'm telling you, man, they need to rework what they think. Okay, because they got paid too much money for too long because there hasn't been any engineer to question what they're doing. That's what it is. And they just, when you get an engineer, they go through the school and start regurgitating. Yes, it's right. Yes, it's right. I need to pass the test. Yes, it's right. Yes, I need the money. Yes, it's right. Where's the guy with the pear, man, and just says, this is bullshit. Okay? This is crap. Who the hell came up with this? Maybe that's why I get kicked out of school so much, because I just don't tolerate the ignorance. It's not right, man. You can't keep saying this kind of stuff and get away with it in science. It doesn't work. You're going to have to prove your theory. And for God's sakes, take the lasers out of the equation, because they're not telling you anything. You're just making up a story to go with the lasers that you checked and made sure that they were in the same square. I mean, for God's sakes, man. That's why I'm making fun of your holes. That's why right there. Okay? That's why I'm making fun of it. Because quite frankly, you just gave us a load of crap, man. I literally had to put waders on to fucking go through it. Okay? People say, oh, Nathan, you need to start using all the right words. You need to start talking just like every other scientist. Why? They haven't gotten it right yet. Why should I talk like them? Why? I don't need to do anything like they do because they don't have it right. Okay. They can't have a provable experiment. They just don't. It's like I see the experiments and I feel like I'm in high school and we're getting ready for a science fair. You know what I mean? And you're kind of late that day and you're like, man, I didn't get it done. I got the best idea in the world. And trust me, I had this idea myself and I did it for my science fair in junior high. I took the hot dogs and I put them in the microwave. And I wrote a report based on the hot dogs exploding in the microwave. Oh, don't, oh, no, I didn't stop there. I took some beans. You know what I mean? I took my chili in there while I was eating it, while I was doing the experiment, getting ready to go to school. Okay. I drew nice pictures on there as they were sitting there cooking. You know what I mean? Yeah, why not? And that was my science experiment. But then again, I look at physics experiments, it's not much better. Okay. If I took out all the lasers in science experiments, man, you wouldn't have much left. What do you quantify? What, go ahead and tell me, what are you quantifying then? I mean, there are some good breakthroughs, man, where they show stuff, but there's not many, man. I guess I'm just disheartened, man. I literally went for the last 2 weeks to get as much information as I possibly can to learn the formulas and learn things in physics. And I kept running across the same damn thing. All of it's the same experiment repeated again and again and again. And you're telling me a different outcome every time. That's it. It's like they all sat around the campfire with the same damn experiment, came up with their own idea. Uh, we're trying to get ahead here. We're trying to do something so that we can go somewhere. That requires you thinking outside the box, to do something different, to do something they say is impossible and prove it is possible. That's what makes geniuses. It's not shuffling along doing the same old thing, man. That's what makes ignorance in this. Einstein wasn't perfect. He knew he wasn't. Okay. Oh, that's another thing. Oh my God. They were saying how atoms are and the tests to show them. And they showed a petri dish and how things move in the petri dish, right? And they said, oh, buddy, look at that. That's an atom. It's moving in a certain direction. Number one, you'll never see atoms in a petri dish. Okay. You don't have the microscope for it, buddy. Let me just tell you that right now. There was one guy who invented the microscope for it, and you had him killed. Okay. I'm sorry, you don't have it. But they had this petri dish, man, and they started showing it, and they tried to convince us, yeah, this was the test that showed us the atoms were right. And guess what the other test was? A laser. It had to be a laser. Why would it not be at this point? That was the other test that they showed atoms are real, laser. They never showed an atom. Mind you, not in any of these things. Yes, it was Rife who created that microscope. The guy was brilliant. But they're just passing it off. How much BS can you take? I mean, are you going to show us the atom or not? Are you going to show an experiment that transmutates that atom into something else? No, not at all. They're not going to do that. All they're simply going to do is tell you to sit there and watch it. And yeah, this looks great in a petri dish. Meanwhile, you never see an atom in a petri dish. They literally scoop shit into petri dishes and look to see how many bugs come out of it. That's what they do. Okay. You go over there and they take that when you go in and they say, oh, this guy has a problem with his intestines. Let's take his poop and let's put it under the microscope and let's see if there's something crawling out of it. That's what it is. And that's about what I think of your experiment when you say it's an atom. Okay. You're full of it. Okay. It's not an atom. That's not what they are. Okay. God, man. Yeah, we're just a laser away from figuring out physics. We should have all invested in a laser company when we were younger. We would have made billions. Oh, oh. Yeah, like they haven't produced one picture of a atom yet. I seen one. I seen something that they tried to say that looked like it, but it was still CGI. It still wasn't an atom. It's because they don't have the structure right at all even to create it. You got to understand, it is energy. It literally is. And energy transmutating to mass. That's what happens. So they don't have any pictures of it because they don't know what it is. They don't even know what they're looking for. They're trying to tell you it's the stuff in a petri dish. Yeah, bullshit. Okay. Oh, it's the stuff in the laser. No, that's just dust in the room. Oh, okay. Oh, you have your physics test tomorrow. Well, don't listen to this show, man. I'll tell you right now, you're gonna hate life afterwards. Better have your laser ready. When they ask, what do you do? Oh, how do you measure gravity? Better tell them it's a laser. That's what they want to hear. Yep. It's so absurd. I don't know what to tell you. They say, oh man, we're putting a lifter in a vacuum. Why? Why? Does it work in space? Well, I don't know. Is it vacuum chamber space? I don't know. It might work. Might have to change it around a little bit to make it work. That's why you have a good engineer on board when you get up there. You don't have a bunch of people looking at each other funny. You can make anything run in reverse if you know how to do it. That's all they did. Just run it in reverse. Gerald told me one time I built my circuit. Just put it in reverse. It works. Yeah, it does. Doesn't mean it's always right. I mean, jeez. Oh, let's see. Air, cobalt, water, light. You got to have some other conversation going on. Oh, love Mondays. The old man grows. Yeah. Oh, tell me the atmosphere wasn't engineered. Oh, it was. Oh, look. Oh, they try to tell you it's chaos theory. That's another one I watched. Oh, man. Chaos theory. Everything's chaos in the universe. Everything's chaos. Have they even looked at the universe? I mean, for God's sakes, everything geometry wise works out in the universe. If all you're using is algebra, of course it's chaos because you never get an equal value because it's not built that way. You always get something that's got more energy in it than what you're supposed to have. And to physicists, you can't have that. It's illegal. They arrest you for having more energy than what you put in. Apparently, that's the whole thing. Chaos theory is a pile of crap. Okay, it really is. Dude, it's just stupid. Okay, it's stupid. Okay, we all know that everything works together. It has to. It must fundamentally come together the right way every time, or else every flower would not look the same. Say, I got red roses. Well, how do you know they're roses at all? If it's chaos theory, they'd be any different kind of flower. They wouldn't all be roses, would they? You wouldn't continuously get a rose every single time you plant the rose plant. Not chaos. Everything has been put down exactly how it's built. And then as weather changes, it transmutates a little bit in order to survive. Everything is already in the genes, already there. They had wolves in the wild that were around nuclear material. In a few generations, their genes had kicked in and they're able to survive it and not even have a problem with it. Why? Because their genetics were already there. If it was chaos theory, then every snowflake would not be a snowflake. It would be a snowball thrown at you. That's what it would be. It'd be like a hailstorm every day. You wouldn't get a snowflake. Everything is precisely done. Everything. This should be a mathematician's dream. Why they would even say chaos theory would even try to exist is beyond me. This is what mathematicians love. Everything that works out. What's the problem with the math? You cannot say everything's a confined system. You have things in front of you that are not confined systems. I got a bunch of them behind me, pal. Not confined systems. Yeah, it's a DC system. Then it goes in and it turns on my ZVS, and then it goes in and it turns on the little wire that goes around the bottom is my number one. My number two coil is not even connected to it. Okay. I went from a closed system with an open loop. Now my number two coil is my open loop. In that system, okay, it's already breaking your rule. It did it as soon as it was created. It broke your rule. It is not always a closed system. A closed system can have open loops in it. And as you use those open loops, you can start to attain more energy. I don't know why they even say it. I don't even know why they say it. You can't have perpetual motion. But if you go to Egypt Museum, okay, you can find a perpetual motion machine that's been running for years. But according to physics, it can't exist. But according to nature, it's right there in the museum. And you can go visit it anytime you're in Egypt. Interesting. Don't you think you should change your theory? Maybe, because the proof is in front of your face. You may want to say, well, perpetual motion can happen. It's mathematically not, 100%. 99% of the time, you're going to fail. 1% of the time, you'll achieve it. That's probably a fact. But it exists. None the same, it still exists. Oh, yeah. I have fun with this, guys. I watched another show. I should stop watching shows because it puts me in a bad mood. I watched this one, man, and they couldn't figure out that plasma was actually the transition into matter. So you take light, okay, and light is, we know what light is, okay? It has a magnetic field component to it, okay? It has a wavelength to it, and it has a gas that it has to go through in order to create the light. The next transition state is plasma. Once you have a plasma, all you have to do is thicken the plasma. The plasma then becomes a solid object, which you know is mass. Okay? That's the transition state. It's always been that way. It'll continue to be that way. Okay? It's what ingredients did you put in the meantime? What frequencies did you put in to change the light? You know what I mean? What temperature did you put in the machine itself to build that out? What resonance did you change? What was the beat frequency that you put in there? Okay? Those are the things that matter to transmutation because that's how it changes. The thunderstorm generator told you that. You have two spheres that are resonant to each other. Okay? One's a full resonant frequency. Okay? The other one is half of that. So you have two. Right? That's simple. What did you do? You ionized the water. That breaks up the molecules in the water. It starts to pull them apart, makes them easier to pull apart. They go in there, they resonate, they break apart. Okay. Then they transmutate and pull in any molecule from the exhaust, grab onto it, and then make another one coming out the other end. That's simple. That's transmutation. Okay. The sun does it. Okay. It takes its hydrogen atom. Okay. And then it transmutates it. That's simple. But in doing so, it made fuel. Oh, man, where's the hole? The hole is everywhere, dude. The hole is freaking science is the hole. Man, it sure brings you in and sucks you dry, man. I'll tell you that right now. It just got to be. They said everything's waves. Oh, my God, dude, I watched this one. It's a wave. It's a wave. It's a wave. What the hell does the wave do? Oh, we're not going to explain that, but it's a wave. It's a wave. Just a wave here. Checking in, just saying it's a wave. Okay? Dude, I was so frustrated. Like, can you please describe what the wave is? No. Your theory begins with a magnet in the center, and you're rotating a magnet. Where's your electrical field? Where's the dielectric to your magnetic? You got to have both. Don't you know that? You have a dielectric, you have a magnetic, but in the middle you have a radiant field, which is how it builds out in energy. No, not any part of that, just a magnet. Okay, that's a failed experiment. I can rotate magnets all day. Doesn't do a damn bit of good. Okay. We would have figured it out by now. Let me just tell you that. We would have already figured that one out. Yeah, Faraday would have had you beat. He liked to rotate magnets. He wrote a whole theory on it. And our science is all screwed up because he did. Thank you, Faraday. I appreciate that. Yeah. The funny thing is, it doesn't take a lot of energy in order to get a mass amount of energy. You have to understand the weak side of fields. The weak side of energy. 3 weak forms of energy produce one very strong amount of energy. It's how they build together. How did you ever turn off the faucet when you turned it on? Is it continuously building? Those are the things that happen. Everybody thinks, oh man, I got to have this powerful field coming out of the gate. No, you're overpower things. The frequency will never work with the other one, so they'll never tie in together. So they fail immediately. Immediately. You cannot come over to an experiment and drop a ton of energy into it and expect it to work. Okay. I'm sorry it doesn't work that way. You have to tie them in first. You have to tie them in and build them together. Oh, man. I can't wait till they figure this one out. What do you want to do? It's like the mag. You put in the magnets, you get cold current. Okay, it gives you the current value. You put in resonance in there that rings the actual metal itself. Once you do that, then you have to put in less energy into it, and you're going to get the same ring. You're going to get the same amount of value as you would put in at 20 volts as you would at 3 volts. Okay, why? Because it goes through less resistance. The amount of resistance buildup is what screws up your experiment. With the least amount of resistance, you end up with a higher power level because the actual entropy in your system, you're able to cool it, which cooling brings you right closer to a superconductor than heat does. Heat takes you away from a superconductor every time. They already know this. They start to freeze magnets in order to make a superconductor. Well, hey, geniuses, let me tell you something right now. When you start putting heat in your system, you're screwing up your superconductivity. You need to make it colder. You need that electricity to flow through your system at a very small rate in order to do this, because it is not the energy that you put into your system that matters. It matters what you're doing in the environment around it. You do not create or destroy energy. Please get that through your heads. You do not create or destroy energy. You pull it in from the environment. We are living in a living ether. Energy is everywhere. We're in the sea of energy, okay? That's the problem here. You're not seeing it. All you're doing by making your magnets rotate is pulling in the energy from the environment, okay? That's it. The tornado gets the strongest where the hole develops at the bottom. That's what's going on. That's why it rips everything up. It's why it rips everything out. But that's exactly how magnets rotate in anything in order to give you energy. You did not create it. You pulled it in from your environment. Your environment already had it in it. You did not create anything. Total misconception on how energy works. It's backwards. Yeah. So frustrating. So frustrating. What's up, Joe? Talking about some holes here. So far we're in physics so far, and we got a lot of brown holes. They're not leading anywhere, man, and they stink like shit. Yeah. We are living in the ether. I mean, if you haven't figured that out yet, we are. You cannot take the center of the earth and say it's the ether and have a field that goes around it, but we're inside that field. We are literally inside that field of that earth. Okay? We're not on the outside where space is. We're on the inside of that. That means that we're in the ether. If we're in the ether, then energy's everywhere. You just have to learn how to pull it out of the environment. I think people misunderstand that. Why does something get an over unity value when it shouldn't? It's because the frequency was correct in it. Why does your spark gap go from 240 degrees down to room temperature? Well, because there's no resistance in the system. It resonates properly to the entire thing. Once it does that, you have free flow. Once you have free flow, you're available for over unity. The system will get colder. That is the sign that it's working. We're in a living ether. We need to treat it like such. Energy is everywhere around us. It's not blowing out everywhere. On the outside, it blows out as radiation. There's a fact, okay? But we're in the living ether. We are, okay? It has a time dilation field that corrects everything for us. Everything does. Every planet, every sun, every single, solar system, everything has a time dilation field. So time is not what you think it is. It's not all linear. It can't work that way. Time depends on where you are and what perspective. Special relativity told you that. Oh man. We literally have energy around us. Yeah, it gets pretty hot when you get old. I can tell you right now, man, the older I get, the less patience I have with some of this stuff. Oh man. Ha! Oh man. Oh, that's funny. Oh my God. Oh yeah, I'll tell you a joke. They said that we lived in a hole, so I went over to the mirror and pulled down my pants and looked. Buddy, we weren't in there. We, we weren't in that one. I guess we got to look for a different hole. Apparently, they have a view of holes that we don't. Oh my God, dude. That's so bad. I think we're living in the twilight zone. I really do. I think the actual physics of the world has surpassed physicists at this point because they decided not to make engineers part of the equation. And when they did, they made a fundamental flaw. Check your work. That doesn't mean check your math equation. It means see if your theory actually holds up in an experiment. Yeah. Well, we had apples falling on one guy's head. We could check that. Heck, I could chuck an apple at him right now if he was alive, and we could find out if gravity works, see if my old arm can get it there or not. Yeah, we can find out. It's ridiculous. Nowadays, oh yeah, we did math. The hole's this big, and there's this big black hole out there. It's going to suck you in, man. You're going to get there, and it's going to suck and suck and suck, and it's going to pull you in, man. And then before you know it, that black hole is taking everything from you, and you're down to pieces, and then we'll put you right out the white hole. I mean, it's just absurd. Is there a black hole? Probably nature's way of getting rid of stuff that doesn't belong in our universe anymore. Usually things explode, man. When things go that bad, you just haven't seen it yet. There you go. You got it right, Vic. Black holes suck and white holes blow. There you go. That's the way physics tells us it works. They're telling us this. We better take their word for it. They wouldn't mislead us in any way, would they? It wouldn't be one of those things. I think there's more holes than that. So let's check in with somebody and let's just find this out. Mike once told us there were some holes. So let me see if let's see if we have that available here. Mike, this is the captain speaking. Have you and Ben been able to fix the transporter yet?
That's what I'm saying. I can explain to you very simply how to verify if that ground, the third prong at the bottom, the circle hole. I think it's 3 prongs, right? 3 holes. You're in Canada? I don't know.
No. It's 3 holes. Yeah, it should be.
So you have the ground. The third hole is the ground. So you could test that ground by. You have the 2 other holes. Are they the same size or is one bigger?
I'm sorry. Say that again.
You have 3 holes. One is ground at the bottom, and the 2 that are at the top are the power. Are they the 2 holes? Are they the same size, or is one bigger?
No. They're the same size.
Same size. So it's 2. You're in Canada?
No, I'm in Michigan.
Michigan. So it can't be the same size. One slit is a little shorter.
Are you sure? Let me see.
Look closely. You need more light in there.
Oh yeah, you're right.
I'm sorry, Mike. Did you say you had the transporter fixed?
Put the voltmeter on AC 120 volt setting. Put 1 prong in the ground and the other prong in the smaller hole. That's your hotline. And if you get 120 volts, that ground is working good. If you don't, if you get less than 120 volts, like 90 or 80, your ground is probably no good on that plug. That could cause a lot of issues for the circuit too, by the way.
Well, the problem is this only goes up to 10 amps and then it blows.
No, you don't need amps. You just need 120 volts is what it should read.
Okay. As long as it doesn't blow my fuse.
Put it on volts, not amps, volts. 120 AC volts.
This should be good to 250 volts. So we should be okay.
Hey, Gerald, come here and listen to this. I can't tell if they're fixing the transporter or not.
Right. So now put 1 prong in the ground, the other prong in the smaller hole, not the bigger one. Does
it matter which one is which?
That's a tough question. It kind of does matter. But anyway.
Wait, so the red
of the 2 holes, other than the ground hole, of the 2 holes that you have there, one is smaller. That is the smaller hole is the power. The bigger hole is the return for that power.
The negative. Okay.
Yeah, you don't want to use that to.
All right. So real quick before I electrocute myself, Mike, which hole do I stick this in?
Don't stick the plug out. Just stick the prong.
If the hole is red, there's so wrong.
The probe has two prongs, 2 metal.
I'm sorry.
Put 1 prong in the ground and the other prong in the smaller of the 2 holes that are left.
But it doesn't matter which one is which.
No, it does. One of the probes, you have 2 probes from the voltmeter. One goes, no, it doesn't matter which one of the 2 goes in the ground. No, it doesn't.
Okay, so I can put the black one in the ground and then the red one in the small slot.
Yes. Sorry,
okay.
I misunderstood you there.
No, it's okay. We're talking about putting things in holes.
Yeah, easy to get confused.
Mike prefers a certain one.
So yeah, if you don't see a 120 volts right away, just wiggle it around till you get a good connection. You should see either 120 volts or like less than that, like maybe 100 volts.
Easy. Yeah, 120.
Okay, your ground is good. You just verified it. It's good ground.
Nice.
Now, just so you know, if it read less than 120, like around 100 or 90 or 80, that ground is no good.
Oh, right. Okay. It was actually slightly above 120. So is that normal?
Yeah, you're good.
It's like 120.30.
The ground is good. Good. Awesome. Just make sure you're firmly connected to that third prong into your circuit.
Something tells me we're never getting this transporter fixed.
If you were to put 1 prong into ground and the other prong into the return, you wouldn't get anything because it's not sourced. You're not hitting source. You want to go from ground from source to ground to get a reading.
Oh.
No, that makes sense. If it's not properly grounded, you're going to be getting a loss.
You're right, Nathan?
Yeah. I'm living right now. I'm barely breathing. Oh my Lord. Nothing like a good 3 holes, is it? Yeah, we missed Ben. I'll be honest with you, man. I hit him up a couple of times, man. He came up when we did the wings thing, but I wish he'd come back a little bit, man. he had some personal things go on, and he was straightening those out, and some health concerns, and he was straightening those things out. But I miss that laugh, man, every day. I miss that laugh. Oh man, Gerald. Dude, we couldn't stop laughing. Like, we just took ourselves out of that whole thing, man, and just like let him go. And Mike, God bless Mike, man. He just kept going. And he was trying to be as straight faced as possible, but we couldn't be, man. That was the best. Oh, love that, man. Yeah. Yeah, man. Dude. Oh, my favorite episode ever, man. Ever. Yeah, Mike was awesome. Oh, it kind of fits for today, man. That's what we're talking about, holes. I mean, there's no serious talk about this, guys. I mean, look, are we in a hole now? It's funny to joke about. Yeah. There you go, Tammy. Oh, man. Yeah. Ben's funny, man. Dude, just his laugh will crack you up. Just his laugh, okay? He was telling us on Mike's show one night, we're sitting there on League of Extraordinary Inventors, right? And he started talking about the squirrels in his yard. He apparently got 2 squirrels out there. One's named Fred. And it comes over and gets the nuts that he puts out for him. But the way Ben tells the story is so much better. You know what I mean? Oh, man, they were grabbing my nuts. They kept grabbing my nuts, and they hid them away for the winter. They got all my nuts. Yeah, I just died laughing. Oh, man, I miss Ben. Yeah. The hilarious guy, man. Oh, see. The hot dog one was good, too. Oh, my God. Freaking Joe and the hot dog, man. Mike made the mistake one night of showing us this big, oh, man, what was it? It was a transformer, but it was a round one, right? And it had a giant hole. It was like this big in there, man. Joe says it's like throwing hot dogs through the hole. All right, man, I'll play it. I'll play it here in a little bit, man. That one was, oh, you need a greatest hits. Well, we need to get everybody back together again and do another show so I can make a Star Trek out of it and we can all have some more laughs. Let me see if I have that one. Oh, man. Oh, that was a Schmucks episode, wasn't it? Oh, man. Here we go. Good old Admiral Jack. Attention, crew. This is your captain speaking. Can I please have everybody assemble at the view screen? Admiral Jack would like to address everybody at once. Admiral Jack, would you like to address everybody?
All these wannabe schmucks, they have a keyboard and they can get on the internet, so that suddenly they're experts.
Did he just call us all schmucks?
Schmuck.
Schmuck.
You're not a schmuck.
I was microdosing mushrooms that day. Not today, but that day I was.
Admiral Jack, we tried to get our transporters fixed. We reached out to the physics community for help. What do you think about it?
I think they're idiots. I think that when it comes to physics, okay, they don't know what the fuck they're talking about. And anybody who pays any attention to them, gives them any credibility, is stupider than they are. That's what I think.
Man, those people in physics sure didn't rub Jack the right way.
Given the chance, Jack will rub your grandma the right way. Don't you worry about that.
Don't rub your grandma the right way.
Oh, yeah. I agree. I totally agree.
It's all bullshit. It's all bullshit, okay?
Admiral Jack, maybe you can help us out with another thing. Joe tried to cook his hot dogs in the warp drive, and he screwed up something with the mass.
And he's made some very elementary mistakes. He violates Einstein's equation equals mc squared. He doesn't know the difference between the mass and the gravitational field, that the weight of an object is W equals mg.
You all heard the Admiral. Let's get this toroid out and let's get everything fixed.
Well, just an example, the inside of the toroid, that's about 3-inch diameter, 3.5-inch diameter.
Was I right to say it's about 6 inches in diameter altogether?
Yeah, maybe a touch bigger. Yeah.
It's an awfully big hole, Mike.
Don't go there.
It's Canadian. There's 3 holes.
All right, so you're gonna hook it up, and then we're gonna
Oh,
throw hot dogs through it like a carnival dude.
Oh my God, I'm choking here now.
This is what happens when you have me on. Don't we already know this?
Yeah.
At least Gerald ain't drawing the circuit for it.
Oh my God, we sound like a bunch of schmucks.
Schmuck.
Schmuck.
You're not a schmuck.
Don't tell me about what other schmucks say. Only I'm the big schmuck here, okay?
Oh my Jesus. Oh, the schmucks. Schmuck, schmuck, schmuck. Oh, that's hilarious, man. Yeah, those Star Trek episodes are good, man. They were good. Oh. Yeah, I do agree with you. Theoretical physics is definitely a crock of you know what. Yeah, it is. Oh, you want the shrooms, Joe? All right. Let me see if we got shrooms here. Don't see shrooms. Hold on. I know I have it. Oh, we haven't played this one in a long time. I'll find shrooms while we do. People of planet Dreamscape, greetings from the Starship Fringe Think Tank.
Welcome to the Plant Dreamscape.
It's an honor to meet you, Gold Lady. We'll be transporting down to the surface in no time.
I must warn you, Captain. Any random thought during transport may have unexpected consequences.
Gerald, gather the away team and meet me in the transporter room. Guys, try to be on your best behavior. That Gold Lady seems like one of those uptight scientist types.
The elite of the most prestigious scientific communities.
Gerald, I don't think that Gold Lady's going to like that.
There you go.
Well, when it comes to women, as me dear departed father used to say, you can't live with them, and marriage is illegal.
You know, there was something I was supposed to remind you guys about. Something about random thoughts. Huh? Oh, well, we'll just figure it out when we get there. All right, Ian, 5 to transport.
Nathan. Oh my God.
This didn't work out for us at all. Oh man, have you guys seen Bernie?
All right.
It's gonna be so great.
Oh man. It's too much fun playing with this stuff. Oh man. All right. Hold on. I found the episode you wanted to see. This is your captain speaking. Joe, can you please report to the transporter room? We need to go back to the planet where you found your strange rock. Bernie's going to meet us down there. Mike, transport us down.
You have 3 holes. One is ground at the bottom, and the 2 that are at the top are the power. Are they the 2 holes? Are they the same size? or is one
Yes.
bigger? Put one prong in the ground and the other prong in the smaller hole. That's your hot line.
Is he daydreaming again? Hey, Mike, transport us down to the surface, please. Okay, Joe, where exactly did you find this strange rock?
And I could sense it. So I'm very attuned to it. I could like sense it as soon as I like start fumbling around with it. I'm like, up there it is, you know.
Well, let's keep moving down the river to the cave where Bernie is. Oh, man, look at all these magic mushrooms.
All right.
Joe, have you ever eaten any of these things?
Psychologically, you know, having high amounts of that crap around wasn't the best for me. You know, like it would, you know, always kind of grab me, and I'm like, oh yeah, all right, that, you know, and this kind of did that, and it was very, very intense, and it wasn't bad.
Well, after careful consideration, I say we eat some of this stuff and see what happens.
Wow. Instant brain fart there.
Are we still in the cave? Why is everything moving? What's going on, guys?
Direct departure. You know, the 90% of the brainwashed boast senior epic legends and pillars.
What the hell did he just say? Oh my God, I'm tripping balls, man.
You know, I'm deep into meditation, you know, and you know, some different spiritual aspects and stuff like that of you know, metaphysics. And you know, I could tell you, I mean, these things, they do have, you know, psychological effect, you know, as far as that stuff goes. And
My lips aren't moving, but I'm still talking. Must be an inner monologue. Awesome. We want to turn it on. We want those effects. We want our mind to work the machine. You know what I mean?
Mhm.
So we can figure out how exactly to do it.
Spinning, the rotation aspect, that is now one dynamic of open system adding to it.
so it's like, oh, well, I mean, what's the difference? It's like, because things don't do this.
Yeah, that's why.
That's why. You see, like, yeah, it's subtle. You're running your finger across something and you're feeling it starting to skip on the surface, but it's smooth. You know,
Yeah.
it's like things don't do this, and this does this. And yes, it's subtle, but it's there. You know, but then there's the more extreme examples. You know, like the thing, you know, taking a lift off, you know, and it's like it just slipped out of your hand.
Oh my God. I can hear Joe in my head and Bernie in my head, but their lips aren't moving.
And then
Which
it's like, so you
isn't
add that
at all.
You know, you
spinning
push it this way, it
to
goes that way.
other
You push it this way,
aspects,
it
like
goes that
bringing
way.
in
And
radiant
the thing
energy
isn't going
from the
exert
environment,
its own
like if it's
force
endothermic
out
cooling
of my
or
hand
from a
that
plasma,
you can
right? All
feel
these
on your
other
hand.
aspects that
You
you
know,
start
like,
combining those
was
dynamics
doing
of extra energy
was forced
in,
down
that
like a
you're
sack of
able to
potatoes
get
to
the
the ground.
exponential gains
And I
in your
couldn't move.
systems.
You have 3 holes. You have 3 holes. You have 3 holes. You have 3 holes. You have 3 holes.
Oh my God. There's no more holes. There's no more holes. There's no more holes. Mike, beam us up.
Boss.
You're right, Nathan?
Yeah, I'm living right now. I'm barely breathing. Brown gas. Oh man, that's great. Oh, nothing like a good little French think tank Star Trek. Oh, yeah, I'll tell you, man. These theories, yeah, I agree with Tammy from earlier. It's just bad, man. Just bad. Never gets old, man. All right, look, hey, let's just play the last one, man, and then yeah, we'll just talk after that. I want to. We got the last one I ever did. This is your captain speaking. Can I please have Ben and Gerald come to sick bay, there's been an accident. From what I understand, Ben, Leonardbot and Joe were on a planet and they were looking at alien phasers and trying to figure out how they worked. Apparently, one just went off.
That's interesting. No, that's very interesting.
Sean, what do you think of this situation?
I love it. Fry it and find out.
So do you think anything can be salvaged?
Or it doesn't allow for loss like other systems.
So, Joe, what really happened down there?
So there were two versions of this, okay? There was the early version, all right,
Okay.
and then there's the now version.
Does the now version involve where his nuts got blown off?
And that once you get enough, once you get the 3 orbs and you get them locked in, they start building energy, and then ultimately.
So are you saying he grew an extra orb?
And it's these infrared, it's like the triangulation of these infrared arrays that causes the orbs to form.
That just sounds bad. Gerald, what do you think happened?
Well, we all know that negatives, they attract positive and negative. They come after each other like crazy, right? They're like lovers in the wind that can never touch. So when those plants are growing and you're pumping negative energy into the bottom of it, how fast can they grow? How big can they grow?
Wow, that's just disturbing. So, Sean, is there any way we can fix him up?
So we're going to take off those capacitors and add our own capacitor. And as we lower that capacitance, then that pulse you were talking about increases, and therefore we can pull out the power out of the Tesla coil.
I just want to stop and recognize how adorable that circuit is. It's so awesome. It's sleek. It's, dare I say, a sexy circuit.
It is. I really believe there's an aesthetic quality to electrical circuits.
Okay, enough drooling. Now that you got the front fixed, how are you going to fix the back?
You can put something in the middle, like let's say if you want to test it with a screwdriver tip, you can put it right into that coil, and then it'll start to get hot. And so that's what's called an induction heater.
I don't know about you, but I sure don't want a screwdriver there. Hey, Gerald, how would you fix it?
What you would do is you would plastic the floor, the ceilings, and the walls, okay? You would seal it like a freaking bubble. You tape every seam, you staple it to the walls, the whole 9 yards. Then what you do is you'd have a small intake hole for your air intake and a big exhaust. And you would put a mass blower on that exhaust.
Well, that doesn't sound exactly right.
The small hole. that's the return.
The small hole's the intake, the big hole's the exhaust.
Yeah, I see that on the O-scope. That's crazy. And look at those arcs. They're insane.
Yeah, you'll notice that they're sword shaped, and that's the shape you'll get with AC on this kind of coil. This is 3.5 inch wide. I'm sorry, 3.5 inch diameter, about 9 inches of PVC pipe wrapped with 34 gauge wire.
What does that tell you about Tesla and that big, gigantic, fat rod you just talked about? Okay, sorry, sounded so bad.
I was trying to stay away from that. Go ahead.
Yep. In a little bit, we'll tickle that Elmo, but for now,
tickling his elbow with high voltage. I saw it last time.
That's funny. My goodness.
Snap into a Slim Jim. Oh yeah.
Oh man, that never gets old. Oh, just twisting everybody's word to make a good story. We got the kids, man. Wow, nothing but good times, man. The Christmas episode was great. Yeah, things got to fill apart after that. That's all right, man. Everybody else is doing good. So, Fun times, man. Fun times. Just blowing the letter pots unit off. Oh man. Now we go to talk about physics again after we have fun and laugh. Oh. Anyway, you know what? If you guys remember, it's all those are on the members thing, and feel free to watch them and have some fun, guys. But I put out a new members video as well today. And we were talking about the Egyptian cross and what it is and what it actually is. And then I put out another video today on resonance. So, yeah. I mean, we got to get somewhere, guys. We got to start making things make sense to the experiments. And you know what I mean? When we resonate something in a room together, we can actually find out that it is entangled to it in some way. So, you know what I mean? How much to it, what the varying degrees are, what needs to be added to the concept. There's a lot to that. I'll agree with that. But it's a starting point. It's to get us to go in the right direction and then build out the theory from there. I'd much rather do that where I have a provable experiment that I can pull off every single day of the week, you know what I mean, and do it right in front of you. And that way we can have something to prove it. You could write whatever you like about it, as long as it makes sense to what's going on. So, yeah, I think a lot of this has to be straightened out in that manner. I mean, some of these theories, they just don't make sense. I mean, I'm sure somebody listened to it long enough to make it seem like it made sense, right? Like you convince yourself that your nickname is cool, okay? Like when Alistair Overeem called himself the Ream. I mean, I don't know that any one of us would think that's cool for a nickname. I guess it makes sense to his last name, but it was a terrible nickname. I mean, the Ream. I mean, what is he doing to people in there? I mean, that's the first thing you think. Sometimes just terrible things you think of, and you should just get it out of your head and then let it go. And I don't think these people do. They write papers about it because they're so convinced of themselves. You know, they got their nice sweater and their fireplace, and they got their, glass of brandy or whatever, and yeah, let it flow. That's great. When is it going to match reality? That's what I'd like to know. Oh man. One step at a time. Well, we all get there. I mean, look, I'm not perfect by any means, man. I do experiments and a lot of them fail. I don't put those ones on my channel because why would you want to look at a bunch of failed experiments? But yeah, for everyone that succeeds, you know what I mean? 99 have to fail. Or I don't know what the number is. It's probably less than that. But yeah, every time, for every success you have a ton of failures. And you got to find a way to work around it to get it to work right. I deal with that a lot. And you always have a new challenge coming in there, and something else is a variable. Like, who knew what high voltage leaching was? I didn't really understand the concept. I listened to Dollard, and Dollard said about it, and then I go, oh man, I have that problem right now. I have some high voltage, and I'm having some frequency transferring over it. But man, once you put it together and you put your Tesla coil with a high HV flyback, man, wow, what a difference. Man, it changed that energy, didn't it? Some understanding we got there, that was a correct path to go on. That was provable, and it was proved out the right way. Yeah. Yeah, Dollar knew what he was talking about. Absolutely. Absolutely. I think part of the problem is when we deal with some of this stuff, guys, we all attribute everything to Tesla, which is a mistake because we're using Odin coils. We're not using Tesla coils, really. And all the Tesla coils, when you pull them out, it's a wrapped antenna. That's what it is. It's much different in the way that it's structured compared to the coil that we use. The coil we use causes compression inside, where Tesla didn't. So why would he know anything about it? I think that's what's hard to see. And it shows up a lot more in geometry coils, like Sean showed us, that compression value that's going on in there. We get a lot more of that. Yeah, send it to me. Yeah, I saw some cool stuff on the internet where some guy was blowing a horn and he blew it into the pipe, and there was gas in there, and it was making the gas go up and down and stuff. That one was really awesome, man. There's some cool stuff going on there. I enjoyed that one. So, yeah, we got to deal with a lot of resonance chambers, guys. That's going to be part of the future. It's already there in your magnetron. It was there in the. You remember the experiment they had with the monks? I don't know if it's an experiment, but what the guy witnessed there. And they had that bowl that they put the rock into. And then they put all the horns over there, and they got the two frequencies. They also got the beat frequency going. And then they had it in a bowl, which is basically a resonance chamber, so that the rock itself, once it hits resonance, it just couldn't stay there because it had so much movement. So it had to leave. And as soon as it got some kind of a spark where it was able to change the field that it was in, okay, which means it went from basically just an energy field that it sat into until it hit some kind of repulsive field, and boom, it was gone. Because once it resonates like that and it has a beat frequency to it, it already broke gravity. It was just waiting to take off. It was waiting for something to give it that spark to move. It kind of tells you a lot about the system that they understood then. And you say, well, can I use speakers to do it? No, because speakers top out, and then they don't give you the extra value that you're in there when you have regular horns and stuff like that. That's why when you go into church, the best thing that there is there's people over there playing the instruments, not the you know what I mean? They have a band in there instead of a bunch of speakers. They just work differently. Yeah, we're in a hole, man. Apparently that's the way it works. We got anal log. Yeah. Oh, it still gets me. Oh. Yeah, we're not digital, that's for sure. Not in this hole. Yeah, the Oregon Energy, man, they were onto it back then. You know, they shut down everything that was everything that had to do with this type of technology. You know, they've shut down, right? So they tell you about the earthquake machine, which is the only thing they let out about it. And then anytime someone brings up anything, they call them fringe or they throw you out. And they don't want to see any part of it because it's going to violate physics as they know it. It's going to change it completely. That's why. Because things are structured everywhere, and the structure comes from the residents. So if they start talking about it, trust me, it's going to change physics. The whole problem is, man, is physics doesn't go into it. So they go, oh, well, we have all these theories and we have a reason behind the theory, but they won't tell you the real reason. Never. Yeah. They don't go into the right answer anymore. That's what's disappointing. So when somebody says, hey, you need to read this person or read that person, it's just why. I'll just do the experiments. If they have an experiment, let me see it. Let me see what they're doing, and let me see if I can't recreate it. But do I want to read a bunch of stuff that could be wrong? And that's the problem I'm having. Every time I look at one of Tesla's patents, well, it's not matching what I'm trying to do because his devices were different. He's dealing in bifilar coils, and then you turn around and he's dealing in a Tesla coil, which is much different than an Odin coil. None of it's matching up. So it's meant to be, misunderstood. But then when we look into geometry coils and we actually see what they are, you go, oh my God, that is the same thing as a mandala. It spells out the same way. Why? Because the patterns on the mandala aren't just the wiring pattern. You should know that. They're all the different things that go on in there. The energy pattern, the frequency pattern, exactly how things build out in water, how they build out in air differently, how sand on the ground changes. All of those things are in the mandala. That's the point. It's trying to tell you something about that winding, set, about what it really is. And you know what I mean? Yeah, we have a ratio in it, but that ratio is in string theory, guys. It's literally how things resonate. And then how many do you have, right? That's basically what it is. And it's a ratio. And the amplitude of the ratio decides how big things are as they build out in nature. Guys, it's by design. This is the design that God came up with. This is why we're here now. It was not random, not by any long shot. We ourselves one day will resonate properly with everything else once we get rid of the distortion. Once we understand constructive and deconstructive interference, we'll start paying attention to it more and do it right. Then we'll be in harmony with our planet and we'll start to gain. We'll go forward. Okay. Right now, we're in deconstructive mode and it's really bad. And it's been this way for a while. We're not at peace with our planet right now at all. At all. We're not in harmony with it. We don't understand it. And it shows. This is what happens when we go down the wrong path in physics and we start to say, oh, this experiment, it's the law, but we can't prove a damn bit of it. Yeah, well, there's your problem. You couldn't prove it and you still come up with it. Matter of fact, you put 200 more papers behind it. Well, guess what? We're done listening. I am. I don't understand the reason why I gotta train my brain to put in all your words when your experiments suck. Sorry. Why should I spend the time to do it? Don't show me a petri dish and tell me there's atoms in there. Atoms way too small to show up in your petri dish, okay? You're not Rife. You did not build that same thing. You are not him, okay? And I haven't seen your microscope do the same thing his does. Why? Because they build economy scopes. They don't build them to find resonating objects. Rife did. Big difference, man. You shouldn't have taken them out. We would have been much further ahead. You know, why does the MWO machine use two different frequencies? Two different resonant frequencies are being used in that machine. Because when you're sitting in the middle of it, it's the only thing that can produce a beat frequency in the middle. That's why. That's the value in it. Otherwise, the machine's junk. Why would you want to test a coil on each side that's putting out scalar waves? Well, if it doesn't have a beat frequency, what's the use? That's the activation. That's the understanding here. That beat frequency is massive. Okay? You have to understand it. You don't have to use Tesla coils to get it either. That's the trick of nature. Yeah. You can use tubes. Just go down, get you a piece of toaster, get yourself a DC system, heat up that piece of toaster filament, and then there you go. Put it in the tube. When you get it in there a certain level, it'll create a frequency in the tube. You can create another frequency in another tube. You get a beat frequency between them as long as they have a value to each other. There you go. That's a Viamana for you. That's how they were doing it with the tubes. And everything came down to two set of frequencies. It's written on the wall in Egypt, guys. Everybody goes, oh my God, look, it's a helicopter. Oh my God, there's a UFO here. Well, yeah, well, let's look at the rest of the hieroglyphs. Let's just take away your little eye candy and get to the real thing. They literally have two things of frequency. And right there is your pulse, which is your beat frequency. It's right there. And then what's right before it? You have your stock that comes up like this. Okay? You have your Aachen right there. And then you literally have a bee. Bees are always attracted to resonance because their hive is resonating. You have the symbol for resonance in Egypt, which is that cross, the Egyptian cross, because only the top resonates, by the way. The rest of it doesn't. This should give you a clue. If you flip it 180 and put another one on top of it, you have two sides that actually do make sense. They resonate together. Yeah, well, it's there. And then obviously plants grow better in resonance. They're telling you a formula. They're telling you information you should learn. It's called the mirror effect. We use it in, what do they call it? Holographic physics, or whatever you want to call it, hologram. That's what it's for. So you can see what it is. Once you build out a shape, you look in the mirror and it builds it out on the other side. It's a hologram. But it doesn't mean it's fake. It just means that it's building out exactly the same thing. It's a mirror effect. It's just like when you go in your CAD program, you put it in the mirror and effect, and it gives you the same exact thing you just put up here, right down here. Same thing. I mean, they're giving you the answer. They handed it to you on a silver platter. I mean, what do people miss? They get the helicopter, they get the tank out there. One is the UFO made by the U.S. Army that has that tail on it. That one's on there. Most people don't mention the comet that goes through there. They also don't mention the lunar shard that came on there, which basically all that stuff gives you a time frame between 1945 and 1955. That's when we knew all of it. All of it was right there. So were they trying to tell you how to time travel, or were they just trying to tell you that they saw the future? Maybe they're trying to say, hey, at this point in time, you're going to figure out how resonance works because they already knew it. How? I don't know. I mean, nobody knows how, but they're definitely saying it. Oh. Oh, man. Well, you can't take the moon away because it has a value to the Earth. And it has to do with tidal force and how water is on the surface of our planet. So it has a direct correlation there. It's not so much that the brightness of the moon. The sun itself, if you take away the sun, then we have no entanglement with it, so we have no energy. We would just be, I don't know, just a sitting mass. So you got to have both. They're all entangled to one another in that fashion. So that much is true. Right on, man. His Ironess, come by and check us out, man. Yeah, see? All about entanglement. But you ring the moon like a bell. Why does it ring like a bell? Oh, it might be because it's resonating something when it's near the Earth, and that resonance itself sets the value in it so that it can entangle itself to the planet. Yeah, it might have something a little bit to do with it. It also tells you something about Mars, where it needs a real moon. I mean, that's pretty simple. It needs tidal force. It needs something that has a mass out there that's big enough in order to pull the water that's under the surface back out to the top. We're not moon builders, but we might be if we want to get to Mars and do something with it. Maybe someday we'll figure that out. You know, maybe Venus will change. Maybe it'll flip the right way and slow down. I mean, that's out of control. They have a massive amount of pressure there on the surface, which means they have a ton of gravity going on there, which is based on the rotational speed and the centrifugal force they're getting it. Well, that's all energy. That's all energy. Has too much energy in it. It needs to calm down. And then once it does, it may become habitable. You don't know. Maybe it lost the rotation value on its axis because of the amount of energy in it. And because it had such force in the amount of crushing power that's on the surface. Man. Yeah, there's a lot to learn out there and a lot of things we can figure out. So 240 dimensions, huh? A lot. Yeah, that. Oh man, even the sonic boom when they get to it, they've negated that. They have negated that. If you haven't figured it out with those bombers yet, they have negated that sonic boom. You don't hear that thing coming. It's silent night, man. You don't hear that thing coming. That thing is through your airspace before you figured out it was there. They negated a lot of that inertia. And it's not hard to figure out, man. Not hard to figure out. You can use graphene, put it on the surface, and it creates a high electrical value. The high electrical value, put it into the system. It matches the electrical value in the atmosphere itself. Once you match that, then you're no longer pushing against that force. It's like a Tesla turbine. It puts out a massive electrical value and spinning, right? Well, what does that like to do? It likes to go into Mach. What's the problem with the Tesla turbine? That the blades themselves could not handle the fact that it was in Mach. Well, it didn't have a problem with the wall. It had a problem because it could not sustain the speed. All the aluminum discs broke apart. It wasn't good enough. So, yeah, there's something to be learned there. And all you have to do is put the little pieces together to see the pattern they went to. And we all know she's the Asian scientist that came up with the pattern to put on that plane. And what did she do? It was cross mesh. Yeah, like we haven't seen that one before. So, yeah. Oh, let's see. What does that say? Took your space drone down to Mexico for a test run. She was fast, 192 miles an hour. Nice. Yeah. Right on, brother. You got a video on your channel? Nice. Yeah, there's something about the rings on Saturn. There's rings on Jupiter. I don't know if a lot of people know that. Oh, let's see. We'll go to Dennis here. And is it the plane, Dennis, that you flew? Or is it basically, is it on your long-term videos? Oh, I think I see it. Okay, hold on. That's just cool, man. Sorry, guys. I heard music. I had to turn it off, make sure we didn't get busted. That could be. You never know. Shows it a hole. Huh. Nice. Oh, here we go. We can take a look at it. Oh, look at that. That's pretty cool, man. Oh, reminds me of your RC days, man. Well, he's got a plane too, man, which he rips up there pretty good. So yeah. Yeah, I watched some of his videos, man. They're kind of cool just to trip out and watch it go. Things are fast too. Oh, really cool, man. Oh man. All right. Check some stuff out. What do we got going on here, man? I don't know if you guys caught it or not, but I did a video on the capacitor bank. And I'll show you. This thing was, yeah, it was not exactly easy to put together. And I'll show you exact reason why. Right there. All those little parts on the one side wasn't the center part, man. It's those little white ones. Okay. You see them come down? Those things are a pain to put together, man. It takes forever to solder them and then twist them and then solder them. It's time consuming. But the board works perfect. I put it on my ZVS, man. they work great. So show that for you guys real quick. Sure, a lot of you already seen it. Each one of these switches here, and it's going to change the resonance value. You'll see it on the oscilloscope go up and down. And we're going to go ahead and put this thing in resonance, and then we're going to try to push it a little bit to see how much spark we can get. All right, let's just set this thing back on the tripod here. There we go. That should be good. All right, let's begin. Let's just turn this thing on to, we're going to turn it on to 9 volts. We'll turn it on. The little green light right here comes on. You can see on our oscilloscope that we're on. Let's just take one of these on the 47s. You can see I already changed the thing already. Here's again. I can tell you right now, this is a pretty weak resonance. But let's go ahead and flip a couple more caps. We're going to go to the 22s. It's pulling in, but it's taking too much body capacitance into account. We'll turn it back off right here with the switch. As you can see, the power goes off. We're going to move this right here. This is our clip that goes on our Tesla coil. We're going to start this again. We can already see a much stronger signal building here. You can see the intensity of the resonance getting better. Let's see if we can hit the wall on it. Well, that looks pretty good right there. Man, that's pretty clean. There we go. And there we go. That was too much. So we'll just turn a couple off. Usually if you hit the 47s, you can turn it off quickly and bring it right back up. Just make sure a couple of these are off. Bring it right back up. That's pretty good, right? Let's see what we can do here. $15 volts right there. There's a 4-foot light right there. That's pretty good. It's lit up. Not a problem there. Bring it close, bring it further away. We're still holding good. We can see right here, we got a breakout. Let's see if we can increase it now. Ooh, the body capacitance did that. Bring it right back down, take it back down out of tuning. Retune it. Put it back. My finger was touching the metal here. I shouldn't be doing that. There we go. We hit it again. Now, as you can see here, when I miss, I'm able to fix it real quick. These right here are ice cold. These fans are doing their job. They're keeping our ZVS nice and cold. What happens when you're out of resonance is that this cap bank will put heat back into your circuit. That's why you need the 2 fans on your ZVS in order to keep it cool. Like I said, they're ice cold. These fans are blowing good. You can see when the field builds out, we're not messing with the fans. They don't turn off. And that has to do with we're on one frequency here. We're on a ZVS, so it directs one frequency a Slayer exciter tries to get with every frequency on every device you have. This circuit doesn't. It likes to be close, and it likes to run one frequency. That means the frequency of the fans will not be bothered by it. So, okay. We said that was too much, so we're not going to show on this last 47 this time. We'll drop a couple 10s in there. We see that our light went off. Now we're seeing some good sparkage. Everything's running clean. There's no mishaps here. We got a fairly good resonance. If you switch this over to AC right now, yeah, no problem getting some nice big sparks out of it. But as you can see, it's running good. We're at 41 volts, not really affecting anything at all. We have beautiful sparks coming out. Our light here is nice and bright and beautiful. This capacitor bank right here. All right. So you can, sorry, ran a little bit. You can see right there that capacitor bank's awesome. It basically puts you right in the resonance value. All you have to do is flip the switches. Your fans right there on your ZVS keep it nice and cold. And that's exactly what you want. You don't want your MOSFETs to heat up at all. And you want the capacitor bank to do its job. And it does that. You basically flip the switches. You saw me there. Sometimes it's wrong. You know, if it's going like this, it's a weak signal. Okay. You know to move the little clip a little bit. And, you know, we're just talking just this much. You move it that much, and then you get in the right frequency, and you know you can push it. Sometimes the capacitance value is wrong. So instead of 47, you put 20 in there and see what it does, see if it scales. Now, can I push it a little bit further and get a little more energy out of it? Yes. You just have to watch the point where you break resonance. Once you do that, the whole system goes down every time. And it basically goes like this. You're in resonance. It breaks, it brings you out of resonance, and then you go back up to another resonance value. Well, we're not hitting those points in that cap bank. The bigger cap bank I have does that. And it'll bring you in between two resonance values. With this one, it was just basically, can I tune it fast enough to put it in AC? Let me tell you that exact process right there. Without that cap bank, the first time I've ever done it, took me 3 days to get it right. 3 days. Okay. Painful the whole time. Put it in the cap bank and you saw it, what, 10 minutes? We're fiddling with the tank for 10 minutes after it's set up, and you're in business. You're ready for AC. Much, much faster. It's just had a thought. Do you think a fish finder could be used to show the signal if you used a coil? I have no idea. To be very honest with you, I don't know. Definitely a good idea. Yeah, no, it wasn't a laser in there. No, there's a little light that goes off, and it's a green light that's on the side of your ZVS. There's no laser going on in this stuff. Thank you, Jarvis. I really appreciate it, brother. Thank you very much, man. Awesome, brother. Yeah, there's no lasers going on in that. I don't have lasers in there. My eyes got burned so many times from welding. I won't be around lasers, man. So I'd have to wear protective gear all the times for that. But you can see how much easier it is, man. So if somebody would like to purchase one of those, man, I got 4 of them available, and they're $100 a piece. And that's a pretty good deal for how long they take to build, because those little wires suck. Okay. So anyway, I have that available. Just contact me on my email, and you can pick one of those up and then make your life a lot easier if you run a ZVS. I do have the STLs fixed on that, so I'll be putting that out so you can take your cap bank and put it on there. I'm working on trying to get that company to still make those the heat sinks the way that you saw them in there versus the way they come out. so much more convenient to put fans on. If I can order a couple of those ahead of time, I think I'm going to. If I can get that heat sink. If they got that heat sink, I'll order a bunch of them in, and then we'll sell them out because that's just so much of a better design with that in there versus the other one. Otherwise, it just costs more money to switch it out. So, yeah. But the ZVSs are exactly the same. So that's a good thing, man. We'll be able to get some stuff, everybody get into the ZVS. Now, I'll just tell you this, the ZVS is different than the Slayer Exciter. Everybody learn the Slayer Exciter, we got to have it 3 feet away because it tries to resonate everything in the vicinity to the Slayer Exciter. The ZVS doesn't work that way. One frequency is what it puts out. So either you're on that frequency or you're not, and that's it. Which, by the way, puts out a stronger resonance at distance in order to entangle it. So much better doing that with the ZVS than it is the Slayer. That Slayer is hard to do that with. You would think it'd be easier because it tries to resonate with everything, which in one way it is. But if you got a computer in the room, if you got some TV in the room, you got anything else, it tries to mess with that. So keeping that stuff clear, if you just had an empty room, it'd be perfect for it. But most people don't. So running one frequency means that your TV won't be messed up. It won't interfere with the computer. None of it. Yeah. That circuit is definitely the pimp, man. Definitely. That circuit is going to become legendary, man. I'm going to tell you that right now. Nobody builds it like that. Nobody builds the power in it like that. And then the ZVS, man, we got the thing down to a science. We know exactly how it works. And Sean is able to, when he does his, he uses copper rods to do this stuff because he found out that the tracers that go in your board, which is basically just the metal strip that goes in there to connect everything together, they start to create heat in them. When they create heat, it pushes back on the MOSFET and blows it. So what he was using is, I think, 1/8-inch copper hollow tubing in order to run that so that it stops that problem. So his MOSFETs last a lot longer. So Sean's awesome at this stuff, guys. He finds all the things. I told him we should put it in resin. You know what I mean? Make a cool design out of it where each thing hooks in and then put the base in resin. And he says, well, Nathan, why don't we just take all the components and put them in resin? And I'm thinking, wow, that's pretty cool, but I don't know how it'll turn out, but that just sounds cool. That's Sean for you, though, man. Sean's a master worker at this stuff. So, yeah, that Slayer Exciter does that. Yeah, you want to get a UFO experience? Set one of those things off next to your vehicle. Woo. Yeah, it'll shut down all your computers. Yeah, it keeps going. Yeah, the self-resonating video, man. That's something that people didn't pay attention to a lot, but should. I put in cold energy, and I got to resonate longer than it should have once I pulled the energy. That's something to understand there. If you can get it to go continuous, you get a runaway. Once you get a runaway, man, nothing but free energy. That's the path in front of it. Yeah. Well, I try to build them real strong, man, so that, you know what I mean? If someone goes to purchase something like that, they don't want the same experience that I go through, right? Where the first Slayer Exciter I built, 2 seconds after I turned it on, I got one little light to light up and it blew up. And I think a lot of Tesla coil people get to that. They go, oh my God, what a hassle. And now the stuff that I put out, you go, Nathan, I can run this PNP circuit for 3 days straight and put some pretty good voltages and good distance in it, and it still runs, man. And you're like, wow, that's not normal. Well, no, it's not. Well, once you understand this, dude, that's like the Cadillac of circuits right there. It's totally different. The ZVS the same way, man. I was frying everything. I couldn't get it right forever. And everybody goes, oh, man, you need a battery cable. A battery cable? Man, I could use a 16 gauge wire right now and it wouldn't heat up. As a matter of fact, I actually take those cheap little dollar store clips, man, and I use those. That wire is so thin, you don't need it if you get this thing resonating properly. And that's what that cap bank's for, man. It's to get people who, just want to get into it and they want to get running right away and they want to have fun with it. They don't want to tinker all day. Well, that's the way to go. The only thing different in what I showed you there versus an AC circuit is there's a separate ground for the AC. There's also another wire that converts it, and it has two diodes on it. And then you have a variac. And the variac is absolutely needed in that. You cannot replace it with a dimmer. You have to use the variac. And it's a protection control device. So when it hums, you know to shut it off or you're completely out of your system. If you don't listen, you're going to blow everything up. That's a fact. I can guarantee that. Oh, man. It also tells you when you're in residence. Once you get past 40 on the dial on your variac and it doesn't start humming, you're in good shape. Now you can start pushing it up to 80. Okay. That's when you know it. You know you're in residence. So I gave you a way to fast tune the system so that you can put it in. There's 20 gauge wire that's inside on those switches. And you ask if you put the voltage in there from AC, is it going to have a problem with it? The answer is no, not at all. Not at all. Not unless you get it out of resonance. Once you get out of resonance, everything starts to burn. But if you're in resonance, which you should be before you start the AC, not a problem at all. It'll free flow, man, and it will rock all day. Now, can you run AC for a very long time? No. No, that's too much pressure on the system. You can run AC for, like a minute, and then you have to turn it off because everything builds pressure and heat. So I haven't built a bulletproof circuit for that one where you can run it all day. I don't know that I can with those parts. I would need a much, much better MOSFET than what I have there. And I don't know that they have one, to be honest with you. Not without spending like $230 a piece. And that's not something that I want to do. But yeah, short test AC. Yeah, Dennis knows. Hasn't had a problem yet. Those boards will last a long time, man. They built them pretty well. It's the circumstances you put them in that blow them up. Now, I have a whole box full of boards. Let me just tell you that and be honest with you. Because I push the living daylights out of these things. I want to know where their breaking point is and why it breaks. And in doing that, Sean did the same thing and came up with his Aruba circuit, which uses that 1/8-inch tubing. We found the flaw in it. We found the flaw, man. So, yeah. We got it, guys. Yeah, there's another way to tune it. And it's not as easy as you think it is, although the inventors made it look easy, is when you put the Tesla coil on the side and you're able to turn the coil, and the number one, it just goes in between a V part, and it touches that number one coil, and you turn that number one coil and dial it in. That one's not as easy as it looks. I could tell you that right now from experience. I once blew one side of the board on that ZVS, and then I just said screw it and left the thing on and took that wire that's a clip and moved it along until I found resonance, man. Then I marked it with my pen, put it in a new board, started right up, worked perfect. Those are the things you do when you test with extreme numbers, man, because you're blowing something up. Yeah, as soon as the variac hums, you turn it off. As soon as it hums. Yeah, that's why you use the variac. Other systems don't give you that. Yeah, old school radio people did that too. Yeah. You asked AI something. Oh, you're in trouble now. For coronavirus specific to old man bills was one of the reference points. Well, what did it tell you? Let's see if it came up with the right numbers. You fed it? What were you feeding? Oh, that probably means use a different MOSFET. So is that what you're talking about? It sounds like what you're talking about. Yeah, different transistors and MOSFETs work different. If you have a better number than the one that I use, by all means, let me know and we'll put it out there. Tom Bearden, GPT, experimental results, chats info. Nice. Yeah, probably tell you, Chat GPT will probably tell you my winding. I said it enough on the show, and people will probably put it in there. Well, the 300 kilohertz is about right. 800 to 100 turns, 0.02 millimeter wire at a 1-inch rod. I could tell you those numbers are off. I tell you that right now. It may work based on the capacitance. That may be a possibility. I don't think that's right. 800 to 1,000 turns. But that's not the part that really bothers me. It's the 1-inch rod that bothers me. Because the turns, you know what I mean, based on the mass of the copper that you're putting in there is how you get your frequency. So there's not enough mass there. I use a 4-inch coil, I use a 1-inch coil. Okay. 0.2 diameter wire means it's using, I want to say it's a heavier gauge. Yeah, 30. I use 32, so it uses a 30. So when I put it in a, let's see, over my left shoulder is 32 gauge. Over my right shoulder is 28 gauge. There's a height difference by far on a 4-inch wide pipe. So I don't know that you're going to get it that small. So you would probably need what, at least 18-inch pipe in order to do that at 4 inches. Now, like I said, it could be capacitance value. If you change the capacitance value in the number 1, it may be a shorter design. But you have to see where the numbers work out on it. Definitely not my build, though. Sorry. I like to look at things. As you can see, I got different coils over here, different coils back over there. I got a bunch more over here. I got a bunch of geometry coils, man. I got a couple rodent coils. Yeah, I got a bunch of coils in here, man. I'm kind of like a freak like that. Got a bunch of those things going on because I like to test them and push them and see what's really going on. So anyway, man, like I said, if you guys want some of that stuff, the ZVS stuff and the capacitor bank, I'll put my email in here. Also, guys, my email's on oh man, it's on the YouTube site on my front page. You just got to click for the email tab and it's right there. Usually in the video in the bottom portion, you'll be able to see that the t-shirt stuff's in there. Also, you know, there's stuff for my email to get a hold of me for these parts and things like that. I'm also on Etsy. And soon, man, we'll have a Shopify account where I can display them on the bottom of the screen for you guys. That's the thing I got to work on in the next couple of days. So we're getting there, guys. Didn't wind it yet. I'm still buying the epoxy for it. Sean's kind of out of commission, man, and I need to get the right epoxy. So I haven't wound it yet. I'm going to glue it and sand it tomorrow and the next day. And then I don't know how to apply the epoxy to the curves because it's got such sharp and long angles. I'm hoping I could just put it on a rod and let it spin, you know what I mean, at slow speed and put it over it. But it may all start dripping to one side. So, yeah, I was hoping Sean would be back in commission where I could ask him and get some advice in that area because I want that coil to come out right. Right on, Darren. I appreciate it, brother, man. Thank you very much for that. Thank you. Have I thought about making a kit? It's hard. Here's the thing. The geometry coil is a hard thing because if I start winding it, I'm giving away somebody's secret when I sell it, and I don't know that that's proper. Okay? If the original person gave it away and was okay with it being out, I wouldn't have a problem with it. But they haven't disclosed it yet, so I can't really do that. It's a violation of their trust. So whether I have it wrong or right to theirs, it's still that way. I mean, the rodent coil we could do it for. Geometry coil, not so much. And I have a hard time with that because I do not like violating any trust of any person. So I don't know that I could do that or show the wind. I could show the testing on it. I think that's available. I do not know that I could show you the winding. It's very specific. Okay. So yeah, I'm sorry about that. I know you know what I mean? It's something that's irritating to all of us, but we kind of have to follow the rules on that. Oh, you're all good, Ian. Ian, by the way, I got to tell you again, I told him this on the email, man. We're looking at those capacitor banks. Total respect for Ian, man. He built us all this big capacitor bank, and you really do not realize how much work goes into that. That must have taken him at least 5 hours a piece or something like that to get each one done or more. I had nothing but respect for you, brother. That was a hard task. That was not easy. I can tell you that right now. But it came out beautiful. Oh, man. Making nuclear batteries. Oh, I don't know that I want to do that. I have to cover my jewels as it is when I walk by the stuff that I build. I don't know that I want to wear permanent tin shorts, if you know what I'm saying. Right on, brother. I appreciate that. Yeah. Oh, man. I'll tell you what. The cool thing is the experiment on the rodent coil. Okay. And where Ben left off on it, or is at right now, I should say, is the jewel thief. And he's got his cool circuit for that. I'm going to take that and I'm going to put a cap bank on each side. Now, I know Ben's got a cap bank on one side and he tries to resonate between the two. I think it's going to be easier with a mini cap bank and pulling it off, or maybe the full cap bank on one side and the mini on the other. I bet you I can hit a resonance value way quicker and get this thing to self-resonate faster. And that's what I'm hoping. We can start pulling this thing in resonance faster. We can get a negative run jewel thief with a car battery or just a DC battery, because we're going to have a better effect pulling the negative through the circuit that way. So that's going to be one of the cool things, man. I have everything to build that cold energy circuit. It's been sitting on my desk for 4 weeks now, and I haven't been able to get to it because I've been building out, coils. You can see them behind me. I'm still working on it because I want to start that Spotify shop, and I better have inventory, for everything. So I'm trying to get a list of, different things I could put on there so we can have good sales on it. And then I'm going to have to find somebody that's in my local area that does this stuff the same as I do, where we can work together in building it. So, yeah, it's a tall task, man, to do that kind of stuff. I kind of jumped in with both feet, and it's kind of, one man army, and I'm the one man that doesn't always work. So, anyway, I'll figure it out, man. It'll all work itself out. You know what I mean? So I just have to find certain days that I work on that stuff, but it means my experimenting won't go that well, which I don't like. So anyway, guys, that's cool, man. Thank you guys all for showing up and hanging out with me, man. Like I said, if you need any of those products, get a hold of me, man. Other than that, don't believe everything the physics tells you, especially about the holes, man. It's just going to leave in the wrong direction. All right, guys, have a great night.
old man builds. The old man builds.
The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.